Before we start talking about dividing fractions, I want to talk about a few concepts that we should already understand. We already know that if I have a whole number and I put it over the number 1, then that is the same as the whole number because this really says 3 divided by 1 is 3. So fractions are division problems. So 6 divided by 3 can be written as a fraction that looks like this. 6 divided by 3, with 6 as a numerator and 3 as the denominator. Well, clearly we know the answer here is 2. But I want you to think about this in a different way. I am going to put both of these as fractions. The number 6 as a fraction would be 6 over 1. Okay? And if I was going to be dividing by 3 over 1, that starts to look a little confusing, right? So let's get rid of the denominator part. So to do that, I want to multiply by something that would make this number here worth 1. So I know that I could cross-cancel the 3 if it was on the bottom. And this is already a 1, so the 1 and 1 would still be a 1. I can cross-cancel this 3 with this 3 and create a 1 here and a 1 here, and 1 times 1 is 1. So now I have 6 over 1, and then this whole thing down here is worth 1. But we know with fractions, whatever we do to the bottom, we do to the top. So I'm going to go up here, and look what I multiplied by on the bottom. I multiplied by 1/3. So if I multiply by 1/3 up here, I can cross-cancel. 3 goes into 6 twice, and 3 goes into 3 once, and I end up with 2 over 1. And I know you're probably thinking, hey, that was really complicated, and we already know that 6 divided by 3 is 2, so why do I need to know that I ended up with this, which is worth 2? Well, the reason I want you to know that is because look at this new fraction division problem here. If I have the whole number 6 divided by 1/2, let's think about that in pictures. Okay, I have 6 and I'm dividing them into halves. If I do this 6 times, I have 6 wholes, and I'm splitting each of them into halves. Well, how many pieces do I actually have when I split those into halves? I have 12. So my answer to this question should be 12. But how do we go about solving that is the question without a picture. Remember that this is a fraction. This is like 6 divided by 1/2, which again looks really confusing because I have all these lines. I have this one, and this is really technically 1 divided by 2. So I need to get rid of this denominator. I want to make it worth 1. The way to do that is to multiply by what we call the reciprocal, and that's when we change the numerator and denominator so that I can cross-cancel them. Well, in this case, I want a 2 on the top so I can cross-cancel it, and a 1 on the bottom so I can cross-cancel it. That leaves me with 1 times 1, which is 1. 1 over 1 we would end up with, which is 1. And anything over 1 is itself, so I have this. However, what I do to the bottom, I must do to the top. So really, when I divide fractions, I'm just multiplying by its reciprocal. That's in order to get rid of this as a denominator. So I have 6 times 2 over 1. Well, 6 times 2, because 2 over 1 is 2. 6 times 2 is equal to 12. So it's the same as when we drew the pictures. Now I just want you to have a basic understanding that this is the reason why we use a reciprocal. We use it to clear the denominator. It allows me to cancel the number that's on the bottom, the denominator of the fraction division problem, and only deal with what's on top. But in order to cancel that, I had to multiply by its reciprocal, and so I have to do the same thing on the top. Now let's just look at it as fraction division. I'm going to start easy. Again, if I were to draw pictures for this, I have 3 wholes, and I want to divide each of them into 1/4. And I want to know how many fourths there are here. Well, 3 times 4, that's 12. To prove that's what I'm doing, we're going to do the same thing as when we were changing subtraction problems with integers using negatives into addition and turning the second into its opposite. We are going to keep the first number the same. However, I want it to be a fraction, so 3 over 1, that's staying the same. I'm going to always turn a division sign into a multiplication sign. And I'm going to turn the number following the division sign into what we call its reciprocal, which is 4 over 1. You switch places with the numerator and the denominator. Well, now I just have a simple multiplication problem. I multiply straight across and I end up with 3 times 4 is 12, and 1 times 1 is 1. Well, 12 divided by 1 is 12. Anything over 1 is itself. Again, let's look at another easy problem. If I have 3/4 and I want to know how many 1/4 are in 3/4, well, clearly that's going to be 3. When we have the same denominator, I can just divide the numerators. 3 divided by 1 is 3. But I can also just change, so I'm going to turn this division sign into a multiplication sign. I'm rewriting the problem, and I'm turning this into, what do we call it? It's a reciprocal, 4 over 1. And now I can cross cancel because I have a regular multiplication problem now. This becomes a 1 and a 1 because 4 goes into each of those once, and 1 and 3 won't cross cancel. 3 times 1 is 3, 1 times 1 is 1, and 1 goes into 3 times. Now here's one that's a little less easy to look at and solve. I have 11/12 and I want to know how many times 3/4 will go into 11/12. So 11/12 divided by 3/4. To solve this, I'm going to keep the first number. So I have 11/12. I'm going to change that to multiplication, and I'm going to change this fraction by turning it into its reciprocal. So in this case, it's going to be 4 over 3. I flipped the numerator and the denominator. Now, this is like the problems we did all day today. We have 11/12 times 4/3. I look to see if I can cross cancel. I can. The 4 and the 12 share a factor. 4 goes into 4 once, 4 goes into 12 3 times. Now I multiply. 11 times 1 is 11, 3 times 3 is 9, 9 goes into 11 one whole time with 2 ninths left over. So 11/12 divided by 3/4 is 1 and 2 ninths. Try these two problems on your paper. Remember that you need to keep the first number the same, change the sign, and change this to its reciprocal. That means you're going to flip these. Do the same thing for this one. You're going to turn this into a multiplication sign, and you are going to change this into its reciprocal. Then you just have multiplication problems, which is what we've been doing this whole week. And you should be able to cross cancel if possible and then solve. Make sure your answer is in simplest form. I know the beginning part of this video is a little confusing. Don't worry about that right now. We'll go over it further in class tomorrow. I just wanted you to have some understanding of the reasons why we can turn that fraction into its reciprocal by changing the place of the numerator and the denominator. Good luck.